This is a new series on calculus. In this series, we cover basics of calculus, application of calculus, integration, finding various and volumes through integration, and gradient descent method. So we start with basics of calculus. I'll go with the syllabus and framing questions according to the syllabus, and we start continuing with this series. So the first question I start with is, what is a set? A set is an unordered collection of distinct objects. Let S be a set if A is an element in the set, and we write this symbol for this notation. If A is not in the set, and we write this notation. So one can give an example of set. Here I have given as the set of all vowels in the English alphabet can be written as a set. Set is any distinct collection of distinct objects. So you can write anything and consider it as a and define it as a set. So once we know what is a set, then we have to ask what is the definition for a function. Let A and B to be two non-empty sets. A function f from A to B is an assignment of exactly one element of B to each element of A, and A is called as the domain of the function f and B is the codomain of the function f. So this is exactly the definition of a function. The function is always defined between two non-empty sets. Give an example of a function. So here I have given y is equal to x square is an example for a function. This is for you as an exercise. Give pictorial representation of a function using an example. So I have a question. In a function, is it allowed to assign the same element of the codomain to the two different elements of the domain? The answer is yes. A function can assign the same element of the codomain to the two different elements of the domain. So the next question, is it allowed for a function to never assign the same element of the codomain to the two different elements of the domain? Yes. We call this function as one-to-one or an injection. So is it necessary for a function to cover all the elements of the codomain? Not necessarily. Okay. So what do we call a function which covers all the elements of the codomain? We call that function as onto or surjective. So as an exercise, you can write different types of the functions using the pictorial representation, and you can identify which is what kind of function it is. Okay, this is a good exercise to identify the types of function. So the next question is, what is a bijective function? A function is said to be bijective if it is both one-to-one and onto. So once the function is bijective, then we can define an inverse function to the bijective function. It's just, if f is a bijective function, we can define a new function from B to A. The codomain and the domain will reverse their roles, and we can define a new function. It is called as an inverse function. What is an even function? Let f of x be a function with x defines the domain. If f of minus x equal to f of x, then this function is called as an even function. What is an odd function? If f of x be a function with x defines the domain, if f of minus x equal to minus of f of x, then this function is called as an odd function. So these are the definition and the types of the functions. Define graph of a function. What do you mean by a graph of a function? If f be a function from the set A to the set B, the graph of the function f is the set of ordered pairs a comma b. A comes from the domain and b comes from the codomain. So you can, as an exercise, plot the graph of f of n equal to 2n plus 1 from the set of integers to the set of another set of integers. And also you can plot the graph of f of x equal to x square. You can try with many different functions and play with it. So my next topic is that limit of a function. To define, before defining limit of a function, we need the definition of what is an open interval. It's a range of real numbers between two endpoints, not including the endpoints themselves. For example, x equal to a comma b, and the x means the x is strictly greater than a and strictly less than b. Those values only x can take. So this defines an open interval. Once you defined an open interval, now you can define what is limit of a function. Let f of x be defined on an open interval about x naught. We say that limit of the function f of x as x approaches x naught is the number L, and we write this with a in a mathematical expression as limit x tends to x naught f of x equal to L. So what exactly it means? It means that if x gets closer to x naught from any direction, f of x gets closer to L, and L must be a finite number. How do we know that the number L is the limit of the function f of x about x naught? So you can do an exercise that choose any random positive number which comes under this function range, and you can find the corresponding domain intervals, open interval, which is determined from delta, and such that whatever the value you take in the open interval, and find the function whatever the value you take in the open interval in the value for x, and find the f of x for this. If you subtract with the limit number which is given to you, the absolute value is always less than epsilon. Then only we say that L is the correct limit of a function. So it's an exercise for you. Consider the function f of x equal to x plus 10. Find the limit of the function at x tends to 5. And another exercise is consider the function f of x equal to x square plus 10. Find the limit of the function as x tends to infinity. So this is all it for now, and we'll continue later. Thank you.